Okay, so hi everyone, Senan on this side, and in this video we are going to see how do we actually do the breadth first search traversal. So basically what you have to do is, in this question it is given that you have a directed graph. You need to do BFS traversal starting from 0, fine, and you need to find all the nodes that are connected to directly or indirectly with the 0th vertex. And for traversing the children, you need to always traverse from left to right given the adjacency list, and you should basically let's look first at the test cases. You are given this 0 1 2 3 4, this tree, and what you have to do is print 0 1 2 3 4, and the manner in which you have to do this is first print the first level, then the second level, and then the third level. So level wise traverse, that is fine, but how do we achieve that? And to do this, we basically use a data structure known as the queue data structure. So that is the first in first out, so that is why we are using queue. For DFS we use a stack. Okay, so let's look at the implementation and understand what we are actually going to do. So what you would be given is the number of vertices, and these vertices start from the index 0. We are clear about that. And you would be given the adjacency list. So first of all, what we have to do is declare this visited array or visited vector. What this does is keeps track of all the nodes that we have previously visited. Let's say we don't keep track of visited, we would go into an infinite loop if there exists a cycle in the graph. So that is why we need to keep a check. Also, we need to return vector int, basically the traversal. So we have to store that answer into some vector. So that is why I have declared this answer array. Now we declare this queue, and since we have to start with the node 0, I push 0 into the queue as well. Now I go into the while loop and I say while queue is not empty, right? Till the time queue has some or the other nodes, we would always go into this loop. Now what I would do is I take out the top element and remove that element from the queue. Top element, by that I mean the front element, first in first out. Now if I say if I have already visited this node, that I have already seen this node before, that means I have processed that node somewhere in the past. So what I do is I continue. That means I don't go after this. I go into the second iteration of this while loop. Fine. If not visited, I would mark as it as visited, because now I have seen and now I will process that node. Okay. So first of all, that would be the part of the answer that we got from this top variable. So I would append that to our answer list. After that, I would find all the elements or all the children of this or all the neighbors of this nodes using this adjacency list, and I would push that into the queue, right? And I would do that till the queue is not empty. When the queue is empty, I get out of this loop and I just return the answer. So how? Let's do a simple dry run on this code. So first I go to 0. First I push 0. Fine. Now I go into the while loop because queue is not empty. Now the top element, since 0 is there, top element is 0, and I remove that from the queue data structure. Now what I do is, since 0 is not visited, I would mark it as visited. Then I would in my answer vector I would push this element 0, and after that I would traverse to the adjacency list and I would push that element into the queue. So now my queue would have 1, 2 and 3 after pushing all the elements, and since queue is not empty, I would go again. Okay, so the top element, I take out the top element, which is 1 in this case. Now I remove that from the queue. Now if I check if it is visited or not, it's not visited. Since this is a directed tree, there won't be a condition where we have visited a node before. So I say that visited of 1 is equal to 1. Now I push that into the answer. So our answer is now having 0 and 1. Now for all the children, I would push the elements into the queue. We don't have any. So after this for loop, my queue would contain only 2 and 3. Now I again go into this while loop. I find out the top element, that is 2. I remove that from the queue and I mark that 2 as visited because it is not visited. Now I would push that into our answer. So now I have 0, 1 and 2 in our answer vector. Now for all the children, I would push that element into the queue. So our queue would have now 3 and 4 as well. Now I get out of this for loop. I again go to this while loop, right? And I take out 3, which is the top element. I remove that 3. I mark that as visited. I push that into the answer. I find all the children and push that into the queue. There are no children for 3, so there is nothing this for loop is not executed. After that, I again go into this while loop. I have a single element, that's 4. I pop that out. I store that element. I pop that element out. I mark that as visited. And now I push back the answer. I append the answer to the list, and I check if there are any children, then push it into the queue. So since when I popped here for 4, I don't have any more elements in the queue. So now queue is empty. So I get out of this while loop and I just return this answer. So we have our 0, 1, 2, 3, 4 as an answer. Yep, that was the video, but let's slightly discuss the time and space complexity. So basically, straightforward, the space complexity would be what? Big O of number of nodes, that is number of vertices. Because first you have big O of V, a visited array of size big O of V, then you store all these elements in the worst case. So again, big O of V, and again for the queue as well, the worst case, let's say you store all the elements back into the queue. So again, the queue in the worst case would have big O of V elements. So that is of the order big O of V, the space complexity, and the time complexity is what? So for every, while the queue is not empty, so what are you pushing? So you are pushing all the nodes or all the edges basically, and you're traversing all the nodes. So the time complexity would be big O of V plus E, not big O of V times E, but big O of V plus E. You are visiting each node once, and as well as for all the edges, you are this for loop for the totality of this running of this code would go through each of these edges, maybe once, maybe twice, depending on directed or undirected graph, but that is the point. And in the end, you would return the answer. So time complexity would be big O of V plus E. E is the number of edges in the graph because this is an undirected graph, and then the space complexity would be big O of n or order n. So yep, that was the video. Hope you enjoyed this, hope you learned something, and hopefully I do a video on DFS. The only thing that you would have to do is change this and this queue to a stack and this front to a top. Otherwise, I think the answer is exactly the same. Yeah, I'll see you in the next video, and bye.